Welcome. Let's take a look at finding the derivative of functions that involve logarithms and fractions. Let's first start with h of x is equal to the natural log of x squared minus 5 over x. We'll first start by using the chain rule to find the derivative, and once we get to the argument, we will need to use the quotient rule. So let's go ahead and do that. So h prime of x is equal to, now since this is a logarithm of an argument, we're going to use the differentiation rule that the natural log of x is 1 over x. So we're going to have 1 over our argument. So this is going to be 1 over x squared minus 5 over x. And then we'll need to multiply by, because of the chain rule, the derivative of x squared minus 5 over x. So this is going to give us 1 over x squared minus 5 over x. Then with the chain rule, using the quotient rule to find the derivative of that argument, we will have the derivative of the numerator, which is 2x, times the denominator, which is x, minus the derivative of the denominator, the derivative of x is 1, times the numerator, x squared minus 5, all over our denominator squared. So simplifying this up a little bit, h prime of x is equal to, in my numerator, I'm going to have 2x squared minus x squared plus 5, simply using the distributive property over x squared minus 5 over x times x squared. I can simplify in my denominator. This x can divide out one of those x's and the x squared. So this would leave us with h prime of x being 2x squared minus x squared is just simply x squared plus 5. And then in my denominator, I have an x squared minus 5 times an x. And I would suggest not multiplying out any denominators, leaving that denominator as x squared minus 5 times x. So that's finding the derivative of h, straightforward, using simply the chain rule in conjunction with the quotient rule. Now, alternatively, I could use the power of some of the properties of logarithms, specifically this property that says the log of a quotient is equal to the log of the numerator minus the log of the denominator. And what this will do for me is it will avoid the necessity for using the quotient rule. So let's take a look at what that would look like. So natural log of x squared minus 5 over x would then become the natural log of x squared minus 5 minus the natural log of x. And then when I go to find my derivative, h prime of x will be the derivative with respect to x of the natural log of x squared minus 5 minus the derivative of the natural log of x. Now, going ahead and finding those derivatives, h prime of x is going to be 1 over the argument of ln x squared minus 5, so x squared minus 5, times the derivative of the argument, so x squared minus 5, minus In the second case, Notice our function is simply ln of x, natural log of x, so we don't need to use the chain rule in this case, and we simply have 1 over x. So then this ends up giving us the derivative being, first of all, the derivative for the x squared minus 5, that is 2x. So we're going to end up with 2x over x squared minus 5 minus 1 over x. Now if I get a common denominator, I'm going to multiply the 2x over the x squared minus 5 by x over x. And I'm going to multiply the 1 over x by x squared minus 5 over x squared minus 5. And so we end up with h prime of x equal to 2x squared. Notice our common denominator is x times x squared minus 5 minus an x squared. So minus 1 times x squared is minus x squared, minus 1 times minus 5 is going to give us a positive 5, or simply x squared plus 5 over x times x squared minus 5. Notice this matches the derivative we got the first time through, but we were able to avoid the usage of the quotient rule by leveraging properties of logarithms to make this derivative simpler to find. Let's take a look at our second function. We have f of x is equal to the natural log of the square root of 3x to the fourth plus 2, all divided by 4x. So you should recognize that whenever we see a radical, that we want to rewrite the function in using exponents, which lends itself to applying the power rule. So natural log of, and that argument is going to include that function inside the square root raised to the 1/2 power. So we're taking the natural log of 3x to the fourth plus 2 divided by 4x. And what I want you to notice is that the argument to the natural log function is 3x to the fourth plus 2 divided by 4x, all raised to the 1/2 power. So if we think about applying the chain rule and the product rule to this, hopefully you're recognizing that this could get rather messy. We'd have 1/2, when we took the derivative of the argument, we would have 1/2, leave the argument alone, negative 1/2 power, then we'd have to take the derivative inside that root, and that involves the quotient rule. So this is going to get rather messy rather quickly. Fortunately, we have rules for logarithms that will help us make this a little bit simpler to deal with. So notice that when you have an exponent or a power in your logarithm, that you can simplify it, and basically that exponent becomes a multiplier or a coefficient. What that means is we can rewrite f of x as 1/2 the natural log of 3x to the fourth plus 2 all over 4x. We can also apply this quotient rule like we did in the previous example, and note that the log of a quotient is equal to the log of the numerator minus the log of the denominator. So f of x I could write as 1/2 times the natural log of our numerator, 3x to the fourth plus 2, minus the natural log of our denominator, which was 4x. And hopefully at this point, this looks like a much easier derivative to calculate. So our derivative is going to be, first of all, we're going to need to use the constant multiple rule with this 1/2 we have out front. So we'll have 1/2 times, and then now we need to take the derivative inside our brackets here. So derivative of natural log, again, is 1 over the argument, and we will be using the chain rule here. So we will have 1 over our argument, which is 3x to the fourth plus 2, times the derivative of that argument. So the derivative of 3x to the fourth is 3 times 4x squared, plus 0, the derivative of 2 is 0, minus, and now the derivative of the natural log of 4x is 1 over the argument, so 1 over 4x, times the derivative of 4x, which is 4. Now, looking at what we have here, notice that this 4 in the 4x denominator can divide out with the 4 in the numerator, and our derivative ends up being f prime of x equals 1/2 times, let's see, 3 times 4 is 12x squared over 3x to the fourth plus 2 minus 1 over x. And we can go ahead and get a common denominator if we choose, but this is a perfectly fine derivative for the function we were given. I hope this is helpful.